Hi, this video is an overview of the Cheminformatics capabilities of the Datagrok platform. By itself, our platform is data agnostic, meaning we can analyze, visualize any data types regardless of which domain or industry they come from. However, by building on top of the platform, it is possible to build really rich integrations that will provide users with extended functionality. In our case, we will be looking at the cheminformatics, and at the core of the cheminformatics are small molecules. Before I go any further, let me tell you where to find everything I will be talking about in a structured way. So on top of the menu there is a search icon, which is also available by pressing Alt Q. And if you start searching for cheminformatics or anything other, it will come out on top. You can also search for commands and even issue commands from that text box as well, but that's a separate topic. So let's go to Cheminformatics. The same page is also available by going to ChEMBL. So this contains a high-level overview of our capabilities. I will be using it as a guide for this presentation since we have quite a lot of functionality. For opening molecular data, no special actions are required from the user. You would typically open any dataset and the platform would recognize molecules in it. Currently we support SMILES format in CSV and SDF format. So let's open a dataset with SMILES. Let's take a look of what's inside, and indeed we only have molecules in the SMILES notation. So let's see what happens when we just drop this file into the platform. Half a second later, we've opened a file with 1000 molecules in it. They are just random molecules from the ChEMBL dataset. Immediately you would notice that the visualization is really fast, so all the molecules are already in memory and the rendering is instantaneous. And by the way, both the beautification, construction of the molecule and rendering, they are happening on the fly as I scroll in the grid. And thanks to highly optimized in-memory database that we use, we are capable of working with huge volumes. For instance, it's easy to open all structures from the ChEMBL database, and I think it's about 2.8 million compounds, and work with them in memory. This will be the subject of the following video. Let's see what we can do with the molecules that we've just imported. When we simply click on the molecule, it becomes the current object in that property panel. So let's take a look at what's displayed there. The first pane is properties, which are basic properties such as molecular weight and other properties like that. Also, we can see the rendering of the 2D structure. We can copy SDF file if we want that. Also, it's possible to render the molecule in this three-dimensional space. And as you can see, we see the real 3D coordinates, and it's not just a two-dimensional molecule displayed in 3D. The next panel is toxicity. This is the results of a predictive model, the one that predicts different toxicity effects of that molecule. The following one is a drug likeness. Essentially, it analyzes a set of predefined fragments and gives a composite score based on how likely it is to be the drug. Another panel is the identifiers of a molecule. So this molecule has only been found in two databases amongst, I believe, about 30 or 40 databases that we support. By clicking on a link, we would go to the corresponding web page. Let's close it. I should also mention that these panels, or how we call them, info panels, can be customized easily by either the user or the IT department or both. And you can target which users will see which panels. So for instance, your medicinal chemists will see predictions for toxicity, but your legal team will see information related to the patents that are associated with that molecule. A user can also suppress any panel by clicking on the settings sign, but we will not be doing that. To look for similar molecules in the ChEMBL database, open the ChEMBL Similarity pane. The following pane would do Substructure Search, so these are all molecules that contain the reference molecule. We can also check for structural alerts from the database of predefined substructures, which is also customizable. And we can do such things as navigate to the PubChem database and retrieve all the information that PubChem contains about that molecule in a structured hierarchical way. The following panel is an example of applying a script to a molecule. So essentially, this Gas-Tiger partial charges is a script that has been added by a user. By clicking on the I sign, we can open its sources. So this is a Python script. It didn't have to be necessarily Python. We support R, Julia, Java, pretty much all the rest of the popular languages. What needs to be done is once you define the inputs and outputs of the script, the system puts it all together. So in our case, it understood that it has to render this Gas-Tiger partial charges panel, since it accepts a value of type string with the semantic type molecule, and it has the panel amongst the script's tags. And then from here, this is a Python script that essentially assigns the output, which is graphics, to the picture rendered using the RDKit library, which gets visualized here. So this is an extremely powerful concept. The end users, well, admittedly power users, can now customize the platform and add more dynamic content and also target it for the real end users. The next panel is the solubility prediction panel, which is running currently. Now it has been evaluated. Again, just like the Gas-Tiger partial charges, this is a custom script, but it's a different script. It's a script written in our language, Grok script. Essentially, it's a macros that we created. What it does is that it calculates a number of predefined descriptors from the molecule, and we'll get to how extract the descriptors later. Then it applies a predictive model that we've trained earlier against these features, and it returns a prediction of solubility as a result. This script can be run either against a table or against a singular value, so this is why we have a few more lines that handle the whole table with things like imputing missing values and extracting columns. But it's also applicable for a singular value, which has just happened. And again, this is an example of deploying predictive models to the end user. Let's close these scripts and come back to our molecules. So clicking on a molecule is not the only way to change the current object and display the property panels. Alternatively, we can sketch it. To sketch a molecule, go to Chem Sketcher, and while we draw the molecule, the information panels are getting updated interactively, which is a pretty cool concept. Let me close the help and Let's open a few more information panels. So you can sketch, modify different things, and see how your predictions are getting different for different things. See if such a molecule exists already in different systems, and so on and so forth. I find it incredibly powerful. Sketching is not the only way to provide a molecule to the sketcher. As it shows in the header, you can simply paste smiles, inchy keys, or different identifiers. Also, it supports names such as, well, let's enter aspirin, and it should go and fetch it. Okay, it's done. Or we can enter stuff like PubChem column followed by the PubChem ID. I remember one from there. All right, it's done. The sketcher also lets you select or filter the dataset using the currently displayed substructure. So for instance, let's go and filter it, and we should see only the molecules that contain this specified substructure. If you find yourself working with the same molecules again, it might make sense to add it to the favorites, and then by pressing on this icon, it's really easy to switch between them. Pressing escape would close the sketcher and reset the filter as well. There are also other ways for performing in-memory substructure searches. Probably the easiest one is to put the cursor on the molecular column and press Ctrl F, and the sketcher would appear on the left. And as you as you sketch the molecule, it shows only the matching molecules. We also support extracting different descriptors from molecules. So let's close the filter. Let's click on the molecule, on the column with molecules in order to see all the actions applicable to that column. So as usually, they would be displayed on the property panel under actions. They are also available under the pop-up menu in a grid. Let's click on the descriptors, and we'll see different sets of descriptors supported by the system. We can select either a whole category, or we can drill down and select individual filters. So let's calculate Lipinski for that 1,000 compounds, and in about half a second the result is returned. So if I remember correctly, yeah, that's about 18 different descriptors. If we want to, we can go ahead and either visualize them or analyze them in some different manner. For instance, we might want to cluster them and see different patterns, or we might want to build predictive models and later deploy it to users. Really, sky is the limit. Another useful functionality is mapping the identifiers of the molecules. So once we click on the map identifiers, we would select the column, the source, which has been auto-detected as smiles. And we would just select to which coordinate system we need to convert it, and we support about 30 different publicly available databases. It is also possible to integrate it with your own company's identifier system. However, this is not the topic of this video. We can convert it to things like inchy or inchy keys. The implementation is pretty fast, so everything should return in a matter of seconds. Yeah, then by the way, we can go ahead and convert inchy to something else, but I'll proceed with anything other. Let's convert it to drug bank. yeah, it's done. And by the way, I forgot to mention, all the actions that you are seeing are completely reproducible. So while I was extracting different descriptors, properties, and stuff, uh, all the actions were being reported to the console, which you can open by pressing tilde sign or going to tools console. So if you can see all our actions were recorded and can be copy pasted and replayed as well. We have a number of different analyses built in. Let's take a look at the similarity search and diversity search. So both of these analyses use fingerprints and the defined distance function in order to find molecules that are similar to the reference. There is another video that describes similarity and diversity analysis in detail, but essentially you can open both side by side, and in the diverse panel you would see instances of the most different classes, and the similarity view shows you molecules that are similar to the reference molecule, which can be either selected from the grid or selected from the similar compounds, or selected from the diverse compounds, or sketched, so on and so forth. It's also possible to select the exact metric to use. We support about 10 of them, and the particular settings of how the fingerprints are calculated. We also have other analyses such as similarity analysis based similarity visualization based on stochastic proximity embedding, but I will not demo it today in order to. Let's open another file and run R group analysis against it. In order to do that, go to Chem, R group analysis. Typically, the first step you want to do is to find out the most common substructure. You can do it in a second by clicking on MCS. And then we would specify column prefix, and we want the visual analysis. And what is visual analysis? We'll find out in a second. It opened a trellis plot with different R groups on X and Y, and on the intersection there is a viewer that visualizes the corresponding molecules on the intersection in the corresponding R groups. It can be pretty much anything, and not necessarily the bar chart that is currently displayed. It can be a scatter plot. I'm afraid there is not enough data for the scatter plot, or anything else. And speaking about visualizations, Datagrok is a modular platform. So once we've specified our semantic type molecule and we provided a renderer for it, which renders the molecule, its rendering is now available in all viewers. So you've already seen it in the grid, in the tooltip, in the property panel, but things like scatter plot will support it natively. For instance, let's visualize R1 versus R2. So you see the molecules are rendered nicely. Or any other viewer for that matter as well. For instance, bar chart. Or form viewer, which is pretty nice for visualizing custom forms. We can go ahead and really design it the way we want it to look, and then present users with that form. Another viewer is a tile viewer, which is essentially a form viewer, but which is repeated for each row. Obviously, it's customizable as well. There are a few more places that I want to show you that contain functionality related to Cheminformatics. One is the collection of scripts. We can go to browse scripts, and then we will just enter the chem tag. So these are all scripts provided by the community that are related in one way or another to molecules and cheminformatics. For instance, this particular script is a script that visualizes a chemical space using a few different algorithms. It's written in Python and it has just evaluated, but let's go back to the scripts and take a look at this particular script. It's your regular Python code that uses RDKit and it accepts a table with the column of type molecules, and it produces three different graphics as an outcome. As you can see, it's only one page of code, including header and the actual script, and it produces nice, really highly customized visualizations. Let's get back to scripts. I will not describe each of them. Most of them are created by the community. Some of them strip salts from the molecules or translate between different identifier notations or visualize stuff. What I want to mention again is that it's easy to write them. They are community driven, and once you've implemented a script, it's trivial to make it available to everyone in your organization or to the public. Another place where to look for chemical functionality would be under functions, chemical functions, which can be found from either help functions and selecting chem, or simply going to chem functions. So these are commands, they are not scripts that are registered with the system via different ways, typically through plugins. They are very similar to scripts. In fact, scripts are function too, and it's possible to execute them right from here. All of them are scriptable and they end up in the console, so it's possible to create macros that you can run again at a later stage. One last thing I want to show is the ability to run substructure searches and similarity searches against databases. This is typically done using technology called chemical cartridge. We support several of them. So on our premises we have ChEMBL database deployed with the RDKit cartridge installed on it. Just out of the box we can go and browse the contents of the database, but that's the topic of another video. What we are interested in today is the ability to run substructure searches. So you would simply create a SQL query, you can see it on the right side, that uses the special syntax. And this is pretty much it. Once this is done and we have parameters specified, as you can see there are two parameters into that query. One is a pattern, which is a substructure, and another maximum number of rows to return. It becomes a regular query in terms of the Datagrok platform, which can be executed, shared, and so on and so forth. So let's just try to run it, and we want to specify a pattern, what we want to look for. Let's okay. Let's assume we want to search for aspirin, and we will run the query, and now it's being executed on the server, and now it's done. We got 387 rows from the ChEMBL database that have aspirin molecule as a substructure. I think this is enough for today. We've only scratched the tip of the iceberg, but I think now you have a better idea of what our cheminformatics support is, what we can do, how we can do it, and also how you can extend the platform yourself. Please check out our other videos for more details, visit our forums, and we are always happy to hear your feedback. Thank you.